Welcome to the session of thermodynamics. So in this lecture we will discuss about the course on fundamental of thermodynamics. Okay. So in this video we will discuss about the basic things about thermodynamics and what is the why the subject is of very important. Okay. So first of all what we come is basically breaking this word thermodynamics into two parts. One is thermo, another is dynamics. Thermo basically means heat, okay, and dynamics means power. So basically what we gonna deal is basically heat in motion, or this thermodynamics deals with the subject where interconversion of heat into work or work into heat is analyzed. Okay. So another scope of this subject is basically that by thermodynamics we can easily able to explain the ability of a hot body to produce work. Okay. Or the transfer of energy from one system to another system. And this thermodynamics can also shows the feasibility of any process. Gradually we will understand this importance of thermodynamics. Okay. First of all what we start is basically the system. Okay. So what do you mean by system? First of all you have to understand what is the system. Suppose this is a block, a square block, and you want to and in this square block, or if you consider it a room, top view of a room, it will look exactly like this. So if you want to find something in this room, suppose some books you want to find, okay, so but you have a prediction that the book may present in the at this corner of a room. Okay, so now you will focus your attention to this corner of the room. Okay, so basically this system is basically defined according to the user and set according to the domain of your problem, means the user's problem. Okay, here your problem is to find the book. Okay, and you are restricting your focus to this region. Okay, and this system may be consisting of real boundary or maybe consisting of imaginary boundary. It is according to the user. Okay, and the region where you are focusing, that will be under investigation, must have certain quantity of matter which has to be investigated. Okay, so then what will be the definition of a system? So then what will be the definition of a system? The definition of a system will be the system is defined according to the user with respect to the domain of the problem, may have real or imaginary boundary, and must have certain quantity of matter to be investigated. Okay, so this is the system, the definition of a system. Rather, now this system can be classified in various ways. Now we're gonna classify system with respect to basically mass interaction. These systems with respect to mass interaction, it can be classified into closed system or control mass system. Another is control volume or open system. Another which can be also classified, that is an isolated system, but I will discuss about it later because it is an special type of discussion. Okay, so basically the two types of system that can be classified with respect to mass interaction is closed system and open system. Okay, or closed system is also known as control mass system, and open system is also known as control volume system. Okay, so what we classified is basically on the basis of mass interaction. Okay, so it can be also known as closed system, another is closed control mass system. Okay, So what we are doing is basically we are classifying with respect to mass interaction. Okay. So the basic characteristics of this type of system is basically the mass interaction is 0. That means if you consider this is a system, the mass interaction across the boundary is 0. That means no mass is interacting across the boundary. Okay. Another important thing about this one is that the identity and the quantity of this mass remains fixed. That is, identity plus quantity is fixed. Okay, in case of a control mass system or closed system. Okay. Another thing which has to be discussed is that the energy interaction. So if this system anyhow expands or collapse with respect to the boundary, then definitely it will do some boundary work. If it is expanding like this is the amount which increased, and if anyhow contract, this is basically the degree of contraction. Okay. So another thing what we can say, the energy interaction which can occur with respect to boundary work. That means in case of a control mass system, only thing that we can check is that mass interaction. Energy interaction is not 0. Okay. So the basic feature of this control mass system is that the mass, the quantity of mass and the identity is fixed. Energy interaction may occur across the boundary in the form of boundary work. And another thing we need to mention is that if you consider this as the system, that means the domain of your problem, apart from this system, what present around it, you can consider it as a surrounding. Okay. But if you consider this a small part in this earth as a system and rest of this as a surrounding, then it is quite absurd. So this surrounding is termed as immediate surrounding. That means the energy interaction which occurs close to the system, the region around it, is basically known as immediate surrounding. Okay. So another thing what we want to say is that, so another classified part of system is basically the control volume system or the open system. So the basic feature of this is that the volume is fixed. That means if you're considering a flow in a particular region, and according to the domain of your problem, if you want to set the system, okay, and so they have definitely here the mass interaction is occurring across the boundary. Okay. So as previous what we discussed about control mass system, there is no interaction of the mass, but here there is interaction of the mass, because if you consider a particular region in 3D space, some entity is coming into the system, some entity is going out of the system. It may be, the system may be consisting of a real boundary, may be consisting of an imaginary boundary. Okay. We will later see for an devices that we use in a practical field that it is consisting of real boundary, but we are considering it as a control volume. On the other hand, if we consider a flow field, then we can consider it as an imaginary boundary. Okay. Another thing is that the boundary of the control volume is known as control surface. That means the surface, the volume is fixed, the surface which you are considering is also fixed. Okay. Another thing which we discussed in a previous one, that the identity is same for an control mass system, but here the identity may change. Okay. So as there is mass interaction is occurring, so the quantity of mass may remain same after the process, or it may not change also. Okay. The two type of mass interaction can occur. One is steady flow, another is unsteady. One is steady flow state, another is unsteady flow state. So what is steady flow state? The steady flow state is that the amount of mass, if you consider this as the control volume, and the surface of this control volume is known as control surface. That is the boundary of this control volume. Okay. Some mass is interacting, that is Mi. Okay. Basically the mass interaction is occurring across the boundary, and definitely some mass is coming out of the system, that is Mo. Under this steady flow state, this Mi will be equal to Mo. That means amount of mass which is getting into the system will be coming out of the system. Okay. Another thing what we can say, that is for an unsteady state, this amount of mass coming into the system will not be equal to amount of mass coming out of the system. Okay, the amount of mass which is getting into the system will not be equal to the amount of mass coming out of the system. That means there are certain accumulation or depletion of the mass of the control volume. Okay, later it will be proved by a continuity equation that the mass is always conserved for a system. Okay, but there is also what we conceive is that energy interaction is also not zero. Okay, so in the previous one what we explained was that in case of a control, for a control mass system, the energy interaction which occurs in the form of displacement work, that is the displacement of the boundary. Okay, not energy in the form of mass. But here what we consider, as the mass is flowing, the energy in the form of mass can propagate across the boundary, and also the energy can also propagate. So here the